This video I would like to introduce a very nice problem of Indian Mathematical Olympiad 2000. Here is the following information: find all integers x, y, z. Okay, we have these two equations, x plus y equals to 1 minus z, and the second equation we have x cubed plus y cubed equals 1 minus z cubed. Okay, so in fact this is very straightforward equation, but it's more tricky. So the hint that I'm trying to give to this problem, just kind of factorization, just combining these two equations, okay, and consider the negative solutions as well, because we have x, y, z as integers, and symmetry, okay, because x and y are playing the same role here. Okay, so go ahead, pause this video if you would like to give that try to this problem. When you want to come back to see the full solution. Okay, let's get into the solution without loss of generality. Okay, so we have x, y, z is a solution, and we have y, x, z is a solution, and we have also minus x, y, z is a solution, and we have x minus y, z is a solution. Okay, because we have symmetry between x and y only. Okay, we're going to start with the second equation. I have x cubed plus y cubed equals y equals 1 minus z cubed. Okay, equivalent. I'm going to factor out this term, which is on the left hand side of this equation. I get x plus y factor x squared minus xy plus y squared. Okay, equals 1 minus z. I'm going to factor this one as well. This is giving me 1 minus z factor 1 plus z squared. Okay, now if you take a look at this term x plus 1, it will be replaced with 1 minus z. Okay, so we'll have 1 minus z here. Then I'm going to cancel out 1 minus z from both sides. Then I'm going to factor out this term as well. So we'll have x plus y quantity squared. If I'm going to distribute this one, I get x squared plus 2 times xy plus y squared. But we have minus xy. So I'm going to put minus 3xy in order to get this one even. Okay, so minus 3xy equals 1 plus z squared. Okay, I'm going to factor this one as well. So this one is giving me z plus 1 quantity squared. If I'm going to distribute this one, it's giving me z squared plus 2 times z plus 1. Okay, but I have only 1 z here. That means I'm going to put minus z. Okay, I'm going to replace x plus y by y minus z. Okay, y minus z. I'm going to bring these two terms to the left hand side of this equation and move over this minus 3xy to the right hand side of this equation. So we'll get 1 minus z quantity squared is giving me minus z plus 1 quantity squared plus z. We'll get 3 times xy. Okay, I will get 1 minus z plus 1 factor 1 minus z plus 1 plus this z here equals 3 times is multiplied by xy. Okay, now this minus z will be cancelled out with this z, and then this number 1 will be cancelled out with this one here, because one is positive, the other one is negative. I will be left with minus 2z factor number 2 here plus z. If I'm going to add this one on this one, is giving me minus, I have minus 4z plus z, which is minus 3z equals 3xy. Okay, number 3 will be cancelled out from the left and the right side of this equation. I will get z equals minus xy. Okay, I have ended with this expression z in terms of x and y with a negative sign in the front. Previously I was working on these equations and came up with this expression. Now I'm going to check the parity of these numbers. Okay, if you take a look carefully at this expression, we have x and y are symmetry here. Okay, so x and y, that means they have the same parity. Okay, in the other word, they both are even or they both are odd. Okay, have the same parity. By the way of contradiction, suppose x and y are even because they have same parity. Okay, that means x equals to k and y equals to k prime. Okay, where is k and k prime are the some natural numbers. Okay, since I have this relationship between x and y, that means z equals minus xy. X, I'm going to replace x with its value. We'll get 2k is multiplied by 2 to k prime. Okay, which is giving us minus 4k is multiplied by k prime. I'm going to replace these facts into this equation. So we'll have x plus y plus z equals number 1. X will be replaced with 2k, y will be replaced with 2k prime, and z will be replaced with minus 4kk. 4k is multiplied by k prime equals to 1. Okay, I'm going to take number 2 as a common factor. We'll have 2 is multiplied by k plus k prime minus 2 times k prime equals to 1. As we know, this is even, this is odd, which is impossible. Okay, this implies x and y are both odd. Okay, because they have same period. Since they are both odd, so that means odd, that means z is odd as well, because odd is multiplied by odd is always giving us odd. Okay, so now I know the parity of x, y and z. Now let's move on to the next step. Okay, I'm going to show x and y are not composite numbers. Okay, suppose y is a composite number. What I mean with composite number, x and y, it can be number 2, 3, 4 or whatever. Okay, it cannot be number 2 or 4 because they are both odd. Since they are odd, they might be number 3, 5, 7 and so on and so forth. Okay, not number 1 because they are composite. Okay, so this implies y equals 1 plus alpha. What is alpha? Is some natural numbers, not include 0. This is the composite means number 1 plus another integer. Okay, so I'm going to replace this fact into the original equation. This one implies z equals minus x is multiplied by y. Y will be replaced with this value 1 plus alpha. Okay, I'm going to take this found fact and insert it into this equation. Okay, so I have x plus y plus z equals number 1 equivalent x. I leave x as is it. I'm going to replace y with its value plus 1 plus alpha plus z. Plus z will be replaced with this one minus x is multiplied by 1 plus alpha equals to 1. Okay, I'm going to distribute this one. We'll have x plus 1 plus alpha minus x alpha equals to 1. Okay, x will be eliminated. Number 1 will be eliminated from both sides. I will have end with the expression of alpha equals x alpha. Okay, this one will be occurred if x equal to 1. Okay, if x equal to 1, that's mean x equal to 1, that's mean y cannot be composite number. Okay, since x equal to 1 and x and y are odd, that's mean y cannot be taking number 3 or 5. And so now let's move on to solve our equation. Okay, now I'm worried to find the solutions of this equation. Okay, I will have many possibilities here. So first, the first possibility, I will have the equation system of z equals minus x, y must be equal to 1. Okay, because z is multiplied by 1 and minus x is multiplied by y. So I'm taking z equals to minus x, y equal to 1 as a first possibility. For the second possibility, I will take z equals x and y equals to minus 1. Okay, then the third possibility, I'm taking z equal to 1 and xy equals to minus 1, because z equals minus xy. Okay, and the fourth possibility, I will have z equals to minus 1 and xy equals to 1. Okay, this is very tricky. Okay, so because this one is not this one, it is different. Okay, because we are working over the integers. Okay, in fact this job must be repeated again if we wouldn't have the symmetry. Okay, now I'm going to go through each equation system here. So I'm going to start with this equation. This is equation number 1, equation number 2, equation number 3, equation number 4. Okay, I have x plus y plus z equals 1. Okay, the total of these numbers equal to 1. I'm going to replace y with its value. I have x plus 1 minus x, by replacing z with minus x, equals to 1. Okay, this number 1 will be cancelled out from the right and left hand side. I will get x equal to x. X equal to x doesn't mean anything. Okay, I'm going to move on to the second equation. Second equation, I have x plus y plus z equals to 1. Okay, so by replacing y with its value, I will get minus 1 plus x equals to 1. Okay, so I will get here 2x by taking minus 1 to the right hand side of this equation. I will get number 2 here. So that's mean x equal to 1. Okay, so we found x equal to 1. So we have the first solution, x equal to 1 and y equals to minus 1 and z, we found z equal to x, which is 1. Okay, so by symmetry also we taking x equal to minus 1 and y equals to 1, z will be the same. Okay, so here is the first two solutions. This one is coming from the equation number 2. Okay, equation number 1 was eliminated, so I have done with the equation number 2. I found these solutions here. Now I'm going to move on to the third equation. So for the third equation, so I have set z equal to 1. So I have x plus y plus z equal to 1. So x for y equals to minus 1 over x. Okay, I will get minus 1 over x plus number 1 z equals to 1. Okay, so number 1 will be eliminated from both sides. I will get x equals to 1 over x. Okay, it's equivalent x squared equals to 1. Okay, that means x is taking two values, minus 1 and x equals to 1. Okay, here is two values for x. So what I did here, I put the solutions of equation number 2, I put them at the top, and I put the equation number 3 here, which is coming with the solution of x equal to minus 1 and x equal to 1. So I'm going to insert these values into the original equation to find y and z. I put the equation number 4 at the top. Okay, to make work nicely and clearly. Okay, I'm going to plug this one into the original equation. I have x plus y plus z equals 1. Okay, by taking the fact x equal to 1, by starting with this one. Okay, so now I'm going to plug x, I'm going to replace x with its value. I will have 1 here plus y, z will be replaced with 1, got 1 equals to 1. Okay, I will get y equals 1 minus 2 equals minus 1. Okay, so I will have the following solutions. We'll get x equal to 1 and y equals minus 1 and z equal to 1. Okay, by symmetry I will have another solution, x equals to minus 1 and y equals to 1, z equal to 1. Okay, here is another two solutions. Okay, so I'm going to find another solution by using the fact x equal to minus 1. Okay, so by using x equal to minus 1, So I'm still working on this equation. So I'm going to replace this one into the original equation, which is x plus y plus z equals to 1. Okay. X will be replaced with minus 1 plus y. Z will be replaced with number 1. The total equal to 1. Okay. So this one will be cancelled out with this minus 1. I will be left with y equals to 1. Okay. Now we will have a following solution. I will have another solution. I will get x equal to minus 1 and y equals to 1, and I will have z equals to 1. Okay. If you take a look carefully at the solution that I just found, you will find it in this set, which I have used with x equal to 1 because of the symmetry. Because of the symmetry. So we don't need to take this one as a solution. This one is enough because the solution that I'm going to put by symmetry, it will be the same. It will be x equal to 1 and y equals to minus 1, which is here. Okay. So this one is this one, and the one that I'm going to write down is this one. So we don't need these two solutions because we already have it. Okay. So I'm going to erase off this one. Now I'm going to move over to the equation number 4. Okay. So equation number 4, I have z equals to minus 1 and xy equals to 1. By using the original equation, x plus y plus z equals 1, I'm going to replace y with 1 over x. So I will get here x plus 1 over x plus z, which is minus 1, okay, equals 1. By moving over minus 1 to the right hand side of this equation, I will get plus 1, which equals to 2. Okay. By multiplying side by side, I will get x squared plus number 1 equals to x. Okay. So I'm going to bring this 2x to the left hand side of this equation. I will get x minus 2x plus 1. Okay. Which is form quadratic binomial. Okay. Which is x minus 1 quantity square equals to 0. Okay. So I will have the solution x equal to 1. Okay. So I'm going to take this fact and insert it. I have x plus y plus z equals to 1. So x equal to 1 plus y, z will be replaced with minus 1. Okay. Equals to 1. So this one will be cancelled out with minus 1, and then I will be left with y equals to 1. Okay. Now I will have a following solutions. I will have x equal to 1 and y equals to 1 and z equals to minus 1. Okay. We don't need to use a symmetry here because we have x equal to y equal to 1. Okay. It will be the same. So now I'm going to take this solution at the top and finish off this problem. So now if you take a look carefully at these both pairs of these solutions, this one and this one are the same, and they came from different equations. Okay. This one came from the equation number 2. This one came from the equation number 3. Okay. So we found the same solutions because of symmetry and number 1, and the solutions involving number 1 and minus 1 only. Okay. So we are going to eliminate one of the solutions. So I'm going to eliminate this solution. I leave only this one and this one. So I will have only 3 solutions available here. Okay. Now I have done with this problem. If you are interested in watching this one, don't forget to support us with your like and subscribe. Thank you for watching. We'll see you in the next video. Bye.